Quiet. Okay, so we stopped here last time. So we're going to start kinematics 1D. So we talked about the number line. Okay, X is a physical quantity that will be the position on the number line. And then we talked about displacement. Displacement is a vector. So it will be the final position minus the initial position. And then we talked about the average. So that will be displacement, you know. I mean, you see, it's a vector. So if it's pointing to the right, it's going to be positive. If it's pointing to the left, it's going to be negative. If left is negative. Okay, so you also have displacement vector in 3D. Okay, so that will be the vector position, and that will be the vector displacement in 3D. It's a vector. Okay, so it has a direction, a magnitude, and a unit. So we talked about adding vectors. So in 1D, it's easy. You just add numbers, right? And then we have this definition here. Average velocity is a vector. So it will be the displacement over the time elapsed. So it could be non-intuitive. So if you have something moving, you know, all the way to the tennis court and coming back to the same place, the displacement is 0. The distance is not 0. The displacement is 0. So the average velocity is 0. And the average speed is not 0, obviously. Okay, so displacement, velocity are objects called vectors. So they have a magnitude, how much, a unit of what, and a direction, which way. Okay, so we talk about that. So if right is plus and left is negative, so if it's moving to the right, you have a positive velocity. If it's moving to the left, you're going to have a negative velocity. So we had those examples here. And then from here, these are very easy. So I don't know, we're going to do a lot of them. So for example, if you move 10 blocks west and 20 blocks east, what's going to be your displacement? 10 blocks east, right? So 10, the magnitude, the unit blocks, the direction east. So that will be your displacement. And then you can divide to have the average velocity. Okay, so you're going to divide 10 divided by 45 minutes. So 45 minutes is 3/4. So 0.75 hours if you want the velocity, average velocity in blocks per hours. Is that clear? If you are asked to find the average speed, so first you find the distance. So what's the distance in that case? 30 blocks, exactly. So you do 30 divided by the time elapsed in hours, if you want in hours. Okay? So they like to trick you with the multiple choices. So it's a typical conceptual question. Understand that displacement is not the same as distance. Okay? So that was number 4. Number 2, if so 10 block south, so it's going to be minus 10. So you divide by the time, that would be 0.5. So minus 10 divided by 0.5 is going to be negative 20, okay, or 20 blocks at south. So typical question, if you are taking the MCAT or whatever graduate exam or something like this, if you are, typical question will be like you have your X and Y, but that could be east and north. And maybe they're going to tell you, okay, you're going to move 1, 2, 3 blocks at east. Okay, So this is your starting point. And then you change your mind, and now you go 3 blocks at north. And you are the one who have to draw. Okay, otherwise it will be inward. So what do you think is going to be your displacement in that case? So you go. Yeah. So Pythagorean theorem, exactly. Okay, so that will be your vector displacement. You connect the starting point to the end point. Okay, you can call that A, B. You don't care what happened in between. It's always the first point to the last point, you make an arrow. Okay, so in physics, that's what we call the displacement. And then how do we find the magnitude? We're going to use Pythagorean theorem. Do you agree? So the notation will be magnitude. So I'm going to use absolute value to make sure there is no negative. So that will be square root of what? Oh, my eyes. Square root of 3 square plus 3 square, 18. And 18 is 9 times 2, is that right? So you can, or you take your calculator, it's easier. Do you agree? So what do you think this angle is? Oh, sorry. Very good, 45 degrees, right? Cut in half. So you can say the displacement has a magnitude, whatever this is. So 3 times 1.4. So 3 square root of 2. Units, maybe it's blocks. And a way, a direction, which way? 45 degrees above the positive x-axis, or 45 degrees in that case will be north of east. But when it's this angle here, so I'm going to introduce the next unit with the angles. When you are dealing with angles, if you go from the positive x-axis, you don't need to write that it's north of east, right? You will know. This is 45 degrees. Will it be absolute value? Here, no, just it means the length. How much? So any vector like you have a vector v, for example, you're going to have how much? So that will be the magnitude. So you can write this way. And then you have a unit, meters, and then you have a direction, 30 degrees. Okay, so for example, if I'm lifting 45 pounds, okay, so I'm going to say my push is 45. Like if you have no weight, right, it's just 45. So it's going to be 45. How much? That will be the magnitude of what? Pounds. Which way? At up, if you are benching, right? Mm-hmm. So this is the magnitude. How much? Of what? Unit, direction, up. Right? Or if you are crazy, you can bunch at an angle. So then you will say 45 degrees, right? I don't know if it's possible. I don't know. 45 pounds, it's already a lot. Okay, so we are back to 1D, which is much easier. So far, so good? Okay, so let me introduce graphs. Position on the number line versus time. And I'm going to explain why. Let's say you have a motion, right, of some particle. I don't know what it is here. So it starts here at 1 meter, right, at t equals 0. When you start your stopwatch, it's there. At 1 second, it's going to be at 3 on the number line. 2 seconds, it's going to be at 4. Then at 3 seconds, it's going to be at 2. And 4 seconds, it's going to be at -1. Do you agree? But it's not convenient to visualize what's happening as a function of time. It's not continuous, right? It's very hard to see. Is it spinning up? Is it slowing down? Is it stopping? So instead, we're going to make a graph here, position as a function of time. But you see, it starts here. T equals 0 is going to be at 1 meter, position 1 on the number line. And then here, t equals 1. And then here, t equals 2. And then it's coming back here. T equals 3. And t equals 4 is going to be there. Do you see what's happening? Okay, so it means you take those positions and you're going to spread along the time here, and then you can visualize what's happening. Do you understand? So this is the position and this is the time. So let's take 2 points here. Let's take the starting point here. So that will be point A and that will be point B. So point A here and then point B. So what's going to be the displacement? So final position minus initial position negative final position, and this is the initial position. So -1, the final, minus initial is 1, so it's going to be -2. Okay, you see, you start from here, you go to there. That will be your displacement. Again, if you are in 2D, this is like a bug. Bzzz, it stopped there. Here, that will be your position, displacement. That will be your displacement. Okay, do you agree? That will be your displacement. Yes? Okay, so what's the time elapsed between here and there? 4 seconds. Do you all agree? You can use that, but it's better to use this. So what's going to be the average velocity? -1/2. Okay, more you do in class, less you have to review for assignment or test, right? So -0.5 meter per second. But now let's look at the slope here. You see, remember the slope? High school or middle school, I don't know. What's the rise here? So the rise is this, right? So what's the rise? -2, okay? Because you go from here to there, so you fall. It's like a fall. What's the run? For conclusion, in a graph, position versus time, if you have a segment, right, connecting 2 points, the slope is going to be the average velocity. You see? Because the average velocity is delta x over delta t, which is the rise over the run. Okay? And that's the definition of a slope. So it's going to be the slope. Unit. What's the unit of the y-axis? Meters. The unit of the x-axis is going to be second. So by looking at the unit, you know that the slope is a speed. It has a unit of a speed. So it's going to be the average velocity. And you can see what's going on. If you remember a little bit of calculus, if you take the tangent, you see you have the slope. The slope is going to be the instantaneous speed, the speed at a given time. Slope is the steepness. What's happening to the steepness here? It decreases, right? So the peak is how far you're going to be from initial position, but the slope, the steepness, it's getting smaller and smaller and smaller. What's the steepness here? 0. Why is the steepness 0? What's happening here? Stops. Very good, right? So it means the instantaneous speed is 0. And what's happening to the slope after that? It increased. So that means you slow down, you stop, and you speed up. So that's why we use a graph, because right away you see what's going on. Here it's harder to see. You have to think, okay, that time interval here is, the distance here is smaller than here. So it means here I'm speeding up and here I'm slowing down. You have to think. Here you don't have to think. Okay, is that clear? So average speed will be the total distance. So what's the total distance? So 1, 2, 3. And so from here to there you have 4, and then 4 and 4 is 8. Is that 9? No, what's the total distance? 8? Is that 8? 1, 2, 3, 4, 5, 6, 7, 8. Do you agree? The total distance. You take a meter stick, you measure from here to there, and then all the way back. So that's going to be the distance over the time. So average speed is going to be 8 divided by 4, which is 2 meters per second. Agree? Just to connect to the real life. But in physics, we will talk about graph. Okay, even when you go to engineering, everything should be explained in a graph, right? It's easier to interpret. Yes.
Supposed to be 9.
9? No, I don't think so. Look, you start from here. So 1, 2, 3, 4, 5, 6, 7, 8.
Start from 1.
So it starts from t equals 0, it starts from 1. Okay, so that will be your y-intercept here. Okay, so why don't you talk to each other? And this one is easy. You can help each other and answer to find the average velocity and the average speed between this point and that point. Okay, so you can help each other, you can discuss. So if it helps you, you can make a number line. You start from 0. See, t equals 0. You are here. You move at a constant speed, 20. So you go to 20. So here, and then you go to 20. Here you are at 10. No, 20 at 10. No, 10. You go to 20 at 10 seconds. You go something like this, and then you come back at t equals 20 seconds. So you want to make sure you know how to read those graphs. So you start from 0, boom, 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 you go here, and then you come back. Exactly. So what will be the displacement? 0. Very good. So the average velocity, as defined by physics, is 0, which is weird, but that's the way it is. The average velocity is 0. Now the average speed is going to be the total distance, which is 20 and 20, which is 40. And what's the time elapsed? 20, which is 2. Okay? You see, if otherwise you see, you start from here. Boom, 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 you go to 20. You change your mind. Boom, 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 and you go back here. So is it a line here or is it a curve?
It's a straight line.
The straight line, which means that the speed is constant. Very good. Okay, it has a constant speed. And then here the speed is also constant, but it's negative. The velocity is negative, which means it reversed, right? So moving to the right, changing your mind, moving to the left. Okay? Here, it really needs to be curved a little bit because you cannot just stop and go, but this is an approximation. So you go, you look at all the distance covered, right? So what's happening between these 20 seconds? You went up to 20, and then you come back to 0. So you did 20 and 20, which is 40. Right? You can make it as a number line. At t equals 0, you are here. At t equals 10 seconds, you are there. And then at t equals 20 seconds, you go back to the same place. So it's a meter, like a meter tape. Okay, so position versus time between A and D. What's the initial position here? 50, very good. What's the final position? 90. So what's the displacement? 40. Okay, which is the rise. It's something, it's the rise. What's the time elapsed? 3. So you're going to do 40 divided by 3 will be your, so the displacement is 40. So 40 divided by 3 will be your average velocity in physics. Yeah, so otherwise you will have to find the distance, the total distance to find the average speed. Is that clear? Yeah. Displacement, the final position minus the initial position. Okay, so in that case, you are here, this is point A, and then you go, this is point B on the number line, and then that's point C, and then you change your mind and you go to point D, and I just want between A and G. Okay, so it should be about here, which is 90. That will be the final. Here is the initial. So the thing that you have to understand is that when you make a graph, x as a function of time, it's just that this is the number line and something is moving. Here, off, I'm tired, I'm moving at a constant speed. Oh, I'm going to be late to physics, so I'm speeding up, and then I'm good. I arrived, and you do that as a function of time, right? So you're going to do here, and then here, and then here. So that could be straight line, and then you're going to be late here. So you go curve, and then again a straight line. So it's just spreading as a function of time. But this is your number line. Just a way, different way to show what's going on. Are we good? So if I ask you the average velocity between C, for example, and E, what's the displacement between C and E? 0. So the average displacement will be 0, but not the average speed. Okay, so if you want to find the average velocity between B and E, okay, in a graph position versus time, you make your segment and you do rise over run. Okay, rise, final position minus initial position. The run is delta t, so it's a definition of the slope. So if you take a calculus class, very often when they start to explain the tangent and the slope, they take velocity as an example. Okay? So now I'm just opening a parenthesis about relative velocity. That will depend on the frame of reference. And that was developed like the Newton, the physics that we are learning was developed by Newton, but he based his work on the work of Galileo, who worked a lot on kinematics. And there was this very famous book here where he was discussing discussing relative velocity. So here it's easy to understand. Let's take this example here. You understand that relative to the ground, the velocity of the person will add up to the velocity of the sidewalk. Do you agree? You're going to add the velocity. If the person is moving in the opposite direction, relative to the ground, you're going to subtract. And someone made a video for me last semester. If you walk exactly the right speed, but opposite direction, you will be at rest relative to the ground. Does it make sense? You can do that experiment. You can do it on a treadmill. When you are walking on the treadmill, this is exactly what's happening, right? If you go 5 miles per hour in this direction and the treadmill goes 5 miles per hour in the other direction, of course, you're going to be at rest. Otherwise, you fall, right? So that's relative velocity depending on your frame of reference. You have those fancy pools, for example. So the idea is to have exactly the same speed as the water flowing. So one speed is positive, the other speed is negative relative to the ground. So you get 0 relative to the ground. Is that clear? So for example, airplane can have a speed or velocity because it's a vector of 100 kilometers per hour relative to the wind, to the air, but the air, so it's against the air. The air has a velocity of 20 kilometers per hour relative to the ground. So what's the velocity of the plane relative to the ground? 80. Do you see? Because it's like the airplane is swimming in the atmosphere, right? So this is counter against the wind. You see, there is a trick if you want to make sure to get it right. You can use it this way. Plane relative to the ground equals to plane relative to the wind plus wind relative to the ground. You see, you can cross out the wind. Okay, that's how we do it. If you have 100 kilometers, now the wind is pushing the airplane, and this is the wind relative to the earth. So then you add up. This makes sense? So this is very intuitive. Another one that is intuitive, relative to the dog, what's going to be the relative velocity? So this is moving at 2. I mean, this guy is moving at 2 relative to this boat. And the barge is moving at 3. So relative to the ground, it's going to be 5. Very good. But here, if you have 3 in this direction, so it's positive 3, negative 2. So relative to the ground, it's going to be 1. Very good. But you have to decide, the ground is this, the dock.
So you have the number to recommend.
Mm-hmm.
So let me understand what's going on.
So if the boat was going at the same speed as the guy, you will not move. You will be always at the same place.
I understand.
Okay.
Yeah. So for the first question, right? You have man divided by dog is what you want for your result.
So man relative to the dog equals man relative to the boat, and the boat relative to the dog.
Which is 2/3.
No. We just man relative to the boat is just 2. Boat relative to the dog is just 3. So plus, yeah.
The slash.
Yes, the slash, exactly. That's just a trick.
Thank you. Now I understand. Question. Relative to the dock, would the man be appearing smooth backward?
Here?
No, second.
Oh, yes. So that's why it's -2. That's why it's 3, -2, because it's moving to the left. So the man relative to the boat is -2. And the boat relative to the dock is 3. So 3 minus 2. Okay, but it makes sense, right? Because you are not going to move away from the dock as fast if you are moving toward the dock. So that's why you need to subtract. Yeah? So let me ask you something. Now, let's take a frame of reference inside the red car. So you are sitting inside the red car, and this car, and you are not moving. Let's say the red car is not moving. Only this one is moving, going straight into you. So the speed relative to you will be 35 or -35. Yes, if this one is not moving. On the frame of reference of someone on the sidewalk, it will be -35. But now, if you are moving and the car is moving as well, so you're going to crash in a smaller time, right? You're going to crash. So what's going to be the relative speed? Huh? No, relative to you. So you are inside. This car is coming, but you are coming also toward the car. So you're going to meet really fast. No, 60. It's going to be 60 because you go toward each other really fast. Right? However, if this one is moving in front of you and this one is 60, do you add or subtract? You subtract. And I don't know if you notice, like when you are driving really fast and another car is driving but not as fast, from your perspective, it's like the car is moving towards you. It's getting closer and closer and closer and closer. Right? So the relative speed in that case will be 5 if they go in the same direction. Here, it will be 60 because they're going to meet in a shorter time. Yes. Because that's the distance. Because relative to us is really, really far. It's very far away. It's like if you take your finger like this, you see, it's sweeping out a big angle like that. It's called parallax if you take an astronomy class. But if you go like that, it's not moving that much, right? Okay. So there is this crazy video, and I do not recommend to try to do it. So the idea is that
everyone, today we're going to be seeing one.
So the idea is that the car is going in one direction and he's gonna run in the opposite direction at the same speed. And when he jump, because the speed will be opposite direction canceling each other, it will be at rest relative to the ground. So it should not be like pushed out. Let's see. But don't do it, okay? It looks very dangerous. See, don't try. So you see, relative to this, he's not moving, right? He's at rest, but he's moving relative to the ground. So he has no issue coming back as long as the frame of reference is moving at a constant speed.
So the same for wind resistance, which is named after that, there goes a radius of signal surveying will come back to make the moon. And so you'll see the moon is still a square snap after. So this is a moon with a sense of square area that is expanding. So we're moving a square band on those sense of square area instead of a mean of the infrared set edge in the form. As they just make expand, so start to take the data sharp maintain. So depending on the matrix field, a surplus from graphite output will expand value from black at green. Tapos, sa glass area ng bonus, naging yung energy at yung glass connected to the electron sa kanilang naman, ang mga binding green, may mga magsalit, ang mga sinabing for binding school sa pet, may meron sa kanilang si Peppa, ang mga binding over the school of the band, may something more than that step. Tapos si
Isn't that cool? The velocity cancel out. Huh? Isn't that cool? You want to try?
No.
Okay, so if I ask you for the pop quiz, if the car are moving towards each other, shorter term, yes, you add. But if they are following each other, you're gonna subtract. So if you have seen video of parachute, you know, when people are jumping with parachute, and then when the guy below open his parachute, is gonna slow down. It seems that it's coming toward you, but it's not what's happening. It's just slowing down, so you are catching up to him. So here you subtract, and here you add.
Same direction as you, but it's slowing.
Slowing down. It's not like it's moving up.
So up. Track.
Yes. Yes. Relative to the frame inside the car. Yes.
Let's talk about the slide mentioning relative speed. Is relative speed and relative velocity the same or not?
That's a good question. So relative speed, you remove the sign, and relative velocity, you can have a sign. Okay, so if this one is so relative to him, so now you add, so it will depend on the which way is positive, which way is negative. So the relative velocity in the case here, if this one is going 2 and this one is going 3, the relative velocity will be -1. The relative speed will be 1. But we talk about either one will work.
Gonna be negative.
Speed cannot be negative because in physics, it's a scalar. So velocity can be negative, or it can have a direction. A speed, no, it's just a magnitude. It's a good question. So a speed is a scalar like energy. Energy, you don't say 2,000 calories per day at north, right? You do 2,000 calories per day. So it's a scalar. Momentum is a vector, or a force is a vector because it has a direction. Okay, and then we define the instantaneous. So let's go back. Okay, that was for the fun. Instantaneous velocity, it's the velocity at a given time. So it's not between 2 points, it's at a given time. It's like in a car, you have the speedometer, so it's at a given time. So it's the slope. That will be the definition of what? In math? The derivative, right? It's the slope. It's a derivative. So velocity is dx over dt. That's a definition of a derivative, right? So it's a limit. So nothing special about it, right? If you remember your math class, for example, between those 2 points here, so 0 and 2 seconds, what's going to be the displacement? The displacement will just be the run. So you have the displacement and you have the time elapsed. That will be your average velocity. Do you agree? Okay, so what is average velocity? It's just the displacement, which is the run, over the time elapsed, yes? And then you're going to bring those time closer and closer and closer to each other, right? So now the average velocity is going to be 12.1. The average velocity is going to be closer and closer and closer to 10. Okay, so 10, when those two times will be very close to each other, this is called the instantaneous velocity. So if you don't remember the calculus class, it's very simple. At a given time, like 1 second, for example, you're going to take the tangent. Okay, and the slope of the tangent, that's going to be the derivative. That will be the instantaneous velocity. Do you agree? Slope, steepness, the tangent. By definition, instantaneous velocity is the slope of the tangent to the curve at the time of interest. Agree? Okay, so we'll get back to that. Acceleration, let's define a new physical quantity. So what is acceleration? Is how fast you are getting faster, or how fast you are getting slower, or how fast you can make a turn. Okay, so acceleration, okay, it's how fast the velocity is going to change. Example of acceleration, gravity, G. Okay, so the acceleration due to gravity is 22 miles per hour per second. So if you start from very far high up, after 1 second of falling, how fast it's going? 22 miles per hour. After 1 second falling from the Empire State Building, for example. After 2 seconds, how fast it's going? 44 miles per hour. After 3 seconds of falling, how fast is going? 66. So an acceleration is going to tell you how fast the speed is changing when you are falling, for example. So that will make sense to you because you are used to miles per hour or 32 feet per second. Or in the metric system, it's going to be about 10 meters per second. So if you manage to fall for 1 second, you hit the ground, the speed will be 22 miles per hour. You will survive. Okay, so it's like you are biking, you crash into a wall, 22 miles per hour. It's okay. I mean, maybe you're going to break something, but you survive. If you fall for 2 seconds, it's like hitting the ground with a speed of 44 miles per hour. Can start to be bad, right? Yes. And 3 seconds, yes, forget it, right? 66 miles per hour. Conclusion, it's not the fall that kills, it's the landing, right? It's the momentum, because if you have a change in momentum, there will be a force acting on you, and you cannot hit without being hit back. Okay, so if you hit the ground with 10 pounds, the ground will be hit you with 10 pounds. So that's the meaning of acceleration. Yeah.
Well, are you constantly being accelerated by gravity?
If I what?
Are you constantly being like accelerated by gravity?
But I mean, if you don't fall, gravity is acting on you. But right now I'm at rest, right? Gravity is pulling on me and the ground is pushing up. But if you fall, yes, gravity is pulling on you and you are accelerating down. Right? So if you watch the movie, for example, the moon is constantly moving, falling toward the earth, but the earth is curving away. Lucky for us, otherwise it's not good if the moon fall on the earth. So a speed does not have to be constant. Okay, so in that case, you see, look at the slope. Let's look at the slope. Is the slope here, the steepness? Think of going up a hill when you are hiking. Look at the slope. Is it getting better? Is it increasing or decreasing? Decreasing. Okay, it's getting better. I mean, if you hike. So the speed is decreasing. Okay? The speed is changing. The speed, the slope is decreasing, which means the acceleration is decreasing as well. So anyway, in that case, the speed is not constant. You can find the average. So how can we find the acceleration? You just do the change in speed over the change in time, and you have the acceleration. So physics is important for athletes, right? They measure their acceleration, you know, how much power they can put, what's the final speed they can reach. The only crazy guy like who could reach those insane speed was Usain Bolt. He's out. I mean, he's not in competition anymore, but he was out of this world when it came to acceleration over a very small amount of time. Usain Bolt. He had flat feet. Oh, is Mbappe is he as good as Usain Bolt when it comes to? Yes, he's fast. I don't like. Yes, I know him, but I don't like football. I don't like soccer. But yes, I know him. Okay, let's try to do this one. Help each other, talk to each other. It's not that he's fast. It means he can change the speed very quickly, right? So it's a yes. Yeah, a lot of research has done on him because he was exceptional. Okay. So average acceleration. So average is the change in velocity over the change in time. It's a vector. So it has a magnitude, a unit, and a direction. So help each other, talk to each other. More you do now. So this is a very simple problem, right? Yeah, so delta V, by definition, each time you see a delta, that will be the final minus initial, right? So each time you see delta, it means final minus initial. We are not going to change the unit, okay? We're going to say, yeah. Exactly. Okay, so, yeah, okay. So only a test. So only a test. So what do you get? So what do you get? 8. Okay? Kilometer per hour per second. So what does it mean? It means that every second you go faster by 8 kilometers per hour. Okay, so it's a rate. Yes. Because just the question. It depends. It depends on because they want to focus on the concept. You understanding acceleration, not so much on the conversion. Yeah. So how fast is it going after 5 seconds? 41? Okay, so about 40, right? Do you all agree? Right? 1 second you increase by 8. 5 seconds, it will be 5 times 8. And we have one kinematics equation now. If you have no initial velocity, v, the velocity is just the acceleration times the rate, times the time. That's the rate. Okay? Okay, now try to do this one. What happens if now you still have an acceleration of 8 kilometers per hour per second? You accelerate for 5 seconds, but when you start the stopwatch, you are going at 50. Yes, what did you say? 90. Do you all agree? Okay, so it means you are still increasing by 8 every second, and you go for 5 seconds, but your initial velocity was 50 when you start a stopwatch, so now you are going at 5 kilometers per hour. So it's like you make $8 an hour, you work for 5 hours, and they are so nice that they give you $50 anyway just to start your work. Because you come from MMC all the way to here, so this, the gas is expensive. Okay, so this is like the y-intercept. That will be your rate, the slope. Agree? If you think money, it's easier. Okay, you make $8 an hour, you work for 5 hours, and your boss is so nice that just to show up, they give you $50. So final velocity equals initial velocity plus the rate times the time. That's a kinematic equation. Or you can say acceleration is the final velocity minus the initial velocity divided by the time. These equations here, it's the same thing. This is the same. Okay? So conversion, it's math. So I'm sure you can do it. So this is very nice because you can visualize. You start with a velocity equals to 0. In that case, you increase by 8 every second. Now, acceleration is like a force. Okay, so the acceleration will have the same direction as the force. The force is to the right, so that will be the engine. Okay, so that will be the direction of your acceleration. So, for example, in that case, what's happening? Faster, you are speeding up. Do you agree? So the force is to the right because you are pushing on the ground is pushing back on you. So the acceleration will be to the right because the force is to the right. You are moving to the right, your velocity will be to the right as well. Do you agree? But be careful. Now here, in that case, so this one is what? Slowing down or speeding up? Slowing down because you have friction. Where is the acceleration? To the right or to the left? To the left. Because the force is to the left. You have a frictional force acting that says, oh, calm down, okay? You're going too fast. This is very dangerous. But is it moving to the right still or is it moving to the left? So acceleration is to the left, but the velocity is to the right. Okay, so don't confuse both. You have to think of acceleration as a force per unit mass, right? So it's a force also. So if the force is to the left, the acceleration is to the left, it's moving to the right, the velocity is positive. If they have opposite sign, it means you are slowing down. If they have the same sign, that means you are speeding up. Agree? And then we will see that even if you are moving at a constant speed, there will be an acceleration because you are changing the state of motion. Okay, so we're going to see that if you have a circular motion, even if you are moving at a constant speed, you need a force here to push you in. So that will be the force, that will be the acceleration. Okay, so don't worry about that. But if you remember the Earth and the Moon, what does the Moon wants to do? It wants to keep going in a straight line at a constant speed and go bye-bye. So it wants to keep going straight line at a constant speed. No, it can't, because what is the force gluing the Moon to the Earth? Gravity. So I want to go in a straight line. No, you can't. You have gravity here. Right? Pulling. So I want to keep going straight line at a constant speed. No, you can't. Right? I want to keep going to that. No, you can't. So this is called a circular motion. And to keep on track, you need a force. That force in that case is gravity, which means the acceleration will be also toward the center, which is a centripetal force, centripetal acceleration. Okay, coming next, just introducing. So in that case, you are moving which way? To the left. So the velocity is negative. Are you spinning up? Yes, so acceleration, same direction. You are moving to the left, but now you are
being stopped.
So you are slowing down, right? So acceleration will be to the right. You see? That's how it works. So if they have opposite sign, slowing down. Same sign, speeding up. Okay, let's do this one, which is maybe not intuitive. You have to use the definition. Okay, so you have to use a definition of acceleration, right? So what's happening? So first of all, you decide, okay, that's going to be plus, that's going to be minus, that's a number line. So before it's going to bounce, it has a velocity of 5 meters per second. And now it's to the left. So the magnitude is the same, but you see it's to the left. So the final velocity is -5. The initial velocity is 5. So don't stare. I see people staring. Just do it. Final minus initial over the time elapsed. What's going to be your acceleration? -10. Is that -10, -5, -10? Over the times elapsed. Which is -1000. Not that intuitive. There is a huge acceleration when you change direction, when you reverse your direction. Because not only you have to stop, but you have to reverse. And you need, for that to happen, there will be a huge force. Okay, you hit the wall will hit you back. So there is a force pushing you. So the acceleration is not 0. Okay? Exactly. So, and then, okay, so that one is easy. So it's is those cars, they cannot stop, right, with a brake, because otherwise it will catch fire. I mean, there will be too much friction. It's not enough to stop the car, so they use those parachutes here. They go from 28 to 13. This is the starting point. This is the last point. When you start your stopwatch, you start at 9 seconds, stop at 12 seconds. What's going to be the acceleration? Yes, -5. Do you all agree? Because you do final -13 minus initial, so -28, divided by the time elapsed, which is 3. So final 13 minus 28 divided by 3 is going to be -5. Do you agree? Where is the acceleration? It's going to be to the left. Why is it negative? Because the force is to the left, right? You have the drag, the air, okay, pushing in this direction. So it's going to be negative. And they both have opposite sign because you are slowing down. Yes.
Parachutes slow the car.
So in that case, they have a little parachute here to slow them down because you have the drag from the air. Right? So you are pushing the air. You are pushing the air. The air is pushing you back. Oh, you know that, right? You have the crazy people. You don't see those crazy people with parachute. You can buy that. Like those crazy people, right? So the force will be to the left, even though he's moving to the right. So he's gonna slow down. I mean, you will be experiencing a huge force to the left because of the drag, and your force is from your muscle. So it's a competition between both.
Yeah.
Exactly. So I don't know. I'm very tiring. I'm just tired just looking at that. Okay, so -5 is the acceleration. It's negative. You go from 28. After 5 seconds, you go to 23. 5 seconds, you go to 18, and so forth and so on. Right? Before getting to that, what do you think? So you can talk to each other. So 2 meters per second, what does it mean? A, B, C, or D? What does it mean? Acceleration of 2 meters per second? Per second. C. Exactly, right? So it means your speed. So here they talk about speed, not velocity, to make it easier. Your speed will change by 2 meters per second every second. It's a rate. How fast the speed is changing. So what do you think here? It's a number line. So every second you are showing the position. Boom, 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 boom.
Right. Acceleration.
Constant velocity. Constant velocity. Because if it was an acceleration, the distance between them will change. Constant velocity, agree? Okay, you want the acceleration to be no. So you remember velocity, acceleration, if they have the same direction, they are speeding up. If they have opposite direction, they are slowing down. So if
No.
no,
C. C.
C,
You would be so.
because if you are moving south, but you are decreasing your speed, no. So the force is opposite, right? So acceleration, velocity, you speed up. Acceleration, velocity, you speed up. Velocity, acceleration, you slow down. Velocity, acceleration, you slow down. So the answer is C. In that case, the acceleration will be south. Is that clear? So this one is slowing down, and the truck is going east, but he's slowing down. So the acceleration will be west. Very good. Okay, so typical conceptual question. West. And that's easy. So start from rest means initial velocity is 0. Final velocity is 25. What's going to be the acceleration? Huh? What did you say? So what's the acceleration then? A, B, C, D, or E? A. Very good. A, right? 2.5. So 25 minus 0 divided by 10. Which one is not a vector? Average speed, right? A speed is a scalar, a distance is a scalar, velocity is a vector, acceleration is a vector, force is a vector, momentum is a vector. Right? Average acceleration. So it's like so average acceleration. It's like a little bit shifted. It's this one, right? Delta x over delta t is the average velocity. When you see average, you see a delta. Okay, let's do some not calculus. Let's connect to math. Okay, let's choose acceleration of 0, and it's a constant velocity 5. So talk to each other, and what you should see for the acceleration here. Nothing, 0. So it's a horizontal line.
Yes.
Is the velocity changing with time? No. So it should be horizontal line, right? What about the position? Is the position changing with time? Yes. It should be a line. So let's see. See, it's moving at a constant velocity. And when you find the slope, rise is 10, run is 2, 10 divided by 2 is 5. So the slope of position versus time is just the velocity at a given time, but the velocity does not change. Agree? Now, what's going to happen if I keep 0 and here initial position is 10? Which one is going to change?
Yeah.
Very good. Right? You have a y-intercept equals to 10 on the number line. So if I want to write the equation, I have a kinematic equation here. There is no acceleration. X equals initial position plus 5t. So it's like y equals b plus mx, right? So that will be your kinematic equation for a constant velocity. Agree? So if there is no acceleration, the position will be at a given time initial position plus velocity times time. Agree? You have the link in Canvas. Yeah, in Canvas you have the link. Okay, let's make it a little bit more complicated. I have an acceleration of 1, 1, 1, and this is 0. So acceleration, what do you expect? A line, okay? The velocity will stay the same or it's going to increase?
Increase by 1
Very good. Okay, so it's going to increase. The slope will be 1 because it's going to increase by 1 for every step of 1 second. And the position, let's see what it looks like. So it's moving faster and faster. Okay, so now we have an acceleration. And I'm going to give you the kinematic equation. It's just to an introduction, right? So acceleration is 1. What's the equation? What's the y-intercept? 5 plus, what's the slope? 1 times t. So the velocity is what you begin with plus the rate at which you are changing velocity times the time.
It's just
Okay. A. I should put A here, right? I should put A. 1 is A, the acceleration, AT. Okay. What kind of graph is that? It starts with a P. Parabola, very good. So it means there is a square somewhere. So X equals position, nothing. Initial velocity is, so it's going to be 5t plus 0.5 times the acceleration times t squared. So don't worry about it, okay? I will give you the equation. But that's the equation of a parabola. The 5 here is going to give you the initial slope here. and that will be your acceleration.
Why?
Okay? Because why? But why the 0.5? Okay, let's see why. Why do we have a 0.5? Can you take the derivative of that? Okay, so what's the derivative of 5t? 5, very good. Plus 1/2. What's the derivative of t squared? Very good, excellent. And we have 5 plus t. Okay, so it's that will be the velocity. It's just to make sure that you take the derivative, you get the velocity. The velocity as a function of time. That's the definition of a parabola. So anyway, don't worry, we're going to get to that. That's just an introduction. What else? Now, we're going to start with initial position. It's going to be 10. And acceleration, I'm going to make it -1. So what's going to happen to the initial velocity? We're going to say... no, I'm going to do 10. That's going to be 0. No, here. Okay, so what's happening here? Decrease. Do you all agree? The acceleration is negative. So the velocity will decrease by 1 every second. Right? So 9, 10, 9, 8. So it's going to slow down, slow down, slow down, slow down. Slow down, slow down, slow down, slow down. What's happening? Look at that. What's happening? Boom. What's happening here? It stopped. It stopped so much. So in the real world, it will stop here, right? But because we are not in the real world, it means there is a force pulling in this direction. So what's going to happen? It's going to reverse. So this is happening when, for example, okay, but if I have a notebook in my hand, where is the force? Down. So if the force is down, the acceleration is down. What's happening now?
Threw it up with an initial velocity and then the acceleration forced it back down to the ground.
Yes, so what's happening to the speed? Decrease, what's happening there? Stop and then speed up. Happening exactly like this, right? You see the magnitude of the velocity, decrease, 0, and then it's going to increase again. And you still have a parabola, but a different kind of parabola. You see how it works? And the last one, I'm going to go to 50. Initial position is 50. A -1. Initial velocity is 0. So now I start from here. The acceleration is negative. So it's moving to the left, but it is increasing. Okay, there is an acceleration because the velocity is negative. The acceleration is negative. So it's accelerating, but to the left. Do you see that? If you look here, look at the slope. What's the slope here? At the top? 0, right? There is no steepness. And what's happening to the slope? Okay, so it's increasing in magnitude even though it's negative. So it means it's go faster and faster and faster and faster. Okay? So this is just to connect to calculus. So I'm gonna I think this one is easy, so I'm not going to do it. Don't think so. No, this one is easy. By the way, those easy problems, it's in my Dropbox. There is a tutorial for that. So here are the equations of kinematics, the big five. Okay, so here you have position as a function of time. If there is acceleration, you see it's a parabola. That will be for the velocity. You see you're increasing, that will be the rate. That's the definition of acceleration. That will be another equation, and I'll show you once we're going to practice. It's going to be easier. But this one is very convenient because what is it that you don't see compared to there? T, the time. So if you have a problem and the time is missing, you're going to use that equation here. So that equation is actually it's the definition of kinetic energy. It has to do with energy. So anyway, don't worry about that. And that will be the definition for average velocity. So this is in the case when you have a constant acceleration. Acceleration can be positive or negative. This is when you have no acceleration. Okay, so you already know those equations here. Okay, so these are called kinematics equation of the big five. And by the way, I highly recommend that as we go along, you want to open your book, textbook, whatever textbook you have. So I recommend University Physics. You can find it. No, you cannot find it. You have to buy it. Okay, and or you have link in my canvas, but you need a textbook. Okay, you really need a textbook. You need to study. So you see here the position. In that case, it does not change, stays the same. In that case here, you have a constant velocity, and when you have a parabola, that means you are speeding up. Okay, I just want to show you an easy way just to introduce how to use the kinematics equation. So the way you want to do it, you want to have your kinematic equation close to you, next to you in your equation sheet. You see, you have those four equations here. That will be the initial position. Many times the initial position will be equals to 0, and you have a problem like that. So usually it will be in words, and you have to do the drawing. But I like this drawing because it explains everything. That means your initial velocity when you start your stopwatch. That means your final velocity when you stop your stopwatch. That will be your acceleration. It's a force, so it means pulling, so it means it's accelerating. What's the displacement of the boat? So you can displacement will be like your position. Okay, if you start initial position here, okay, so x, it will be like x, right? So you can we do it? So I just show you how we. Yes. You can. What's your question?
Can you use one equation just reorganize it to find it? Like isolation just.
Yeah, so you can reorganize this one. You can say delta x equals initial speed plus 0.5 at squared. So don't forget that delta x is just the final position minus the initial position. Okay, so when you see v sub 0, it just means initial velocity. When you see v, it means the final velocity. X is the final position, and x sub 0 is the initial position. So for example, here you have a number line, and you can decide here that your initial position is 0. That will be your final position, so you are looking at delta x. Agree? So you are looking at delta x. I'm going to put a question mark here. Acceleration is 2. Final IDC, which means I don't care. Initial velocity is 6. Time elapsed is 8. So I need an equation with x, a, initial velocity, and the time. So you have equation 1, 2, 3 is not really an equation, but or 4. So which equation do you want to use? 4, I don't have the final velocity, but you can, if you want, in the first step. If you want to use 4, you will have to say final velocity is initial plus 80. And once you have the final, then you can use 4. So you do it in 2 steps. If you want to do it in 1 step, what's going to be the equation that you're going to use? 1. Do you all agree? You see? So final position equals initial position. They don't specify, so you say okay, it's 0.
So if they don't specify, it's in a 0.
Yeah, you can make it to 0. Yes. And what's the initial velocity is 6 times 8 plus 0.5 to 8 square. Do you agree? Is that 48 plus 64? Okay, so just to show you that it's not that hard, but you need to have your equations next to you, and then you try to solve. It's like a game, but you want to make sure you have a nice drawing next to it. Okay? So there is a class after